Good afternoon or good morning, wherever you are. Welcome to another seminar of topics in computer engineering. As I mentioned, we are towards the end of the semester, and as an advertisement that the next semester we'll have again this seminar series, and the applications are open, fully remote participation. And full in English, another edition that we will have in the second semester. And today we have a guest lecturer, an IEEE ComSoc guest lecturer by Filip De Turck. As usual, Filip, I don't spend time in introducing the bios of our speakers because they are large, rich, and can be easily found online.
Yes.
But if you want to say some words about yourself, more than welcome. And then for the attendees, prepare your questions. We'll have around 15 minutes towards the end for interacting, Philip. And it's a topic that, as I was telling you, we are investing time, students, research. What is holographic-type communications? How to do research that could be meaningful for this area. So looking forward to learn more about what you are doing, what you see that our community is doing, and let's see if we can collaborate and do some joint research. Okay. Thanks,
Okay.
Philippe.
Okay. Thank you, Christian. And dear students, welcome to this lecture. It's my pleasure to give this lecture of about 40 minutes. And then, of course, I will be happy to interact with you and answer questions. And maybe I will also ask questions to you, maybe. So maybe just as a brief introduction to myself. So I'm based in Ghent University in Belgium. So here you see the partial map of Europe. As you can see, hopefully you can see the pointer here, yes. And Belgium is in yellow here. So we are close to England, France, Germany, the Netherlands, Luxembourg. And I'm also part of imec. imec is a research institute in Flanders, similar to Fraunhofer in Germany. And my research group is called the IDLab Research Group, which stands for Internet Data, Internet Technology and Data Science Lab. We have many experts in our research group, and we also collaborate a lot with industry partners. So that's really something that we put focus on. And I know Christian is also a person, a well-known researcher on a global scale who also likes to work with industry partners. The list with industry partners here is not exhaustive, so it's just some examples of industry partners that we work with. My main expertise is on network softwarization, network automation, service delivery. I was also editor-in-chief of an IEEE Transactions journal, so network and service management. So feel free in your future careers to submit to this journal, or maybe during your master's already. And I was also a chair of the IEEE Technical Committee on Network Operations and Management. And so this IEEE Technical Committee is one of the 28 technical committees inside ComSoc Communication Society. So here you see the entire list of technical committees. And I highlighted the Network Operations and Management Technical Committee. And these technical committees are very interesting also for young researchers. If you find the topic interesting and you want to start building a network, so getting to know people that work on a topic, have personal conversations with people, organize workshops, special issues, and so on, then these technical committees are a very good starting point. So you can contact the officers, they are published online. You can contact them, get in touch with them, and then this is always a very good acceleration to improve and extend your personal network. So this is a small recommendation. So I mentioned softwarized networks. So this means that we bring software to the network, so not only hardware, but also software. And the most important element is that we bring virtualization concepts to the network. And this is similar to cloud computing. So I assume most of you, if not all, are familiar with cloud computing. So if I would ask you, what is the main driver for cloud computing to be successful? So it was launched about 20 years ago, and then the main driver to be successful was the availability of virtual machines, so that on a physical computer, physical machine, you can start several virtual machines and you can start serving multiple users at the same time by making use of these multiple virtual machines. And the same reason is that if we can virtualize networks, so that we on a single physical network, we can run multiple virtual networks, then we can also start serving multiple customers, providing service guarantees to all of them, thanks to these concepts. And this is really a game changer in the network technology, also in industry. So let me explain you very briefly. Maybe you're already familiar, but I will explain it briefly. So even if you're not already familiar, um, it will be interesting to learn what is network function virtualization, because I will come back to this once I explained holograms and volumetric media delivery. Then I will also explain how virtual network functions can be of interest. So if we consider a home environment, then there are multiple devices in your home, and typically there is a home gateway. And on the home gateway, we have different functionality. There is a DHCP server, there is an NET router, a firewall, also quality of experience monitoring software. For instance, if we have TV streams or video streams that we display on screens inside your home, then we also monitor the quality of experience inside the home gateway. And then a typical other device is a set-top box, so STB, which contains a decoder for a digital TV, storage, so that you can record movies and TV programs, middleware that allows you to interact through remote control and to start recording, stop recording, play a certain TV program, and so on. For this, we need middleware on the set-top box. And also we have a streaming client, so this is the software that starts streaming the files and make sure that we can see the videos on the screen. So if we look at these functionalities on the home gateway and the set-top box, these are typically called network functions. And when they are executed on these boxes, then they are executed inside your homes. But if we virtualize them, so virtualized network functions, VNFs, then they will be executed not in your home, but in a remote data center. And the data center can be close by, but can also be far away in another country. But then we softwareize these functions, and they run as software components inside a remote data center. And this is a very important evolution, because then we don't need these devices in your home. You just need to connect the different screens to the network sockets so that they have internet connectivity. But all the other functions that are listed here, they are no longer executed inside your home. And there are many advantages. First, from point of view of a network operator, because we can maximize resource utilization and also optimize energy usage, because if all the functions they run on separate devices in each home, they need to run permanently. But if they are in a data center, then we can run many of them on the same machine, making use of virtual machines or containers inside the data center. And also in terms of updates, this is a very important advantage. When we update network functions, then we can very fast and easy deploy them and configure them. And it's much easier than changing software on a dedicated device at home. In a data center, we can overnight quickly and efficiently update network functions. And also for the service provider, there are many advantages which are listed here. So we can dynamically scale network and computing and storage resources based on service requirements. So we can make use of elasticity properties of cloud computing. And we have a reduced time to market for services. So if we have a new service, we can quickly introduce it and customers can make use of it very fast because they don't need to buy the equipment. They don't need to connect manually. And it can be done automatically thanks to the software in the data centers. Okay, so this was a very important topic that I wanted to introduce first. And the second topic, before we will delve into holograms and volumetric media delivery, is the topic of adaptive service delivery that I want to share with you first, because it's important to understand this basic concept, is that if we have a video file that we want to convey over the network and show on a screen, then in case of adaptive service delivery, we will divide the file into small chunks. So each chunk, for instance, of 4 to 10 seconds. And for each small chunk, we will provide a low quality version, a medium quality version, and also a high quality version. So this is what you see with the different numbers here. The low quality version corresponds to number 1, medium quality number 2, and high quality number 3. Okay, and the higher the quality, the higher the bit rate that you need over the network. And now the important element is that at the client side, so here you see the client, for instance, who watch a movie on a smartphone or a tablet. And as you can see here, at this device, at the client device, we will make an estimation of the available bandwidth. And okay, so let me, okay, good. An estimation of the available bandwidth. And there is an algorithm here that calculates which video quality level can be transported efficiently over the network. So based on the estimation of the video quality, as you can see here on the screen, here is the estimation of the available bandwidth. And then at the client side, a decision is made. Now we will request low quality one. At this moment, we have a high bandwidth available, then we will request a higher bandwidth. And here we have a drop, so then we will request medium quality and so on. So this is the algorithm that YouTube is using. So I believe this talk is also streamed through YouTube. So the same algorithm is being used when this lecture is delivered over the network. Okay, and we will also use it for holographic type communications. Okay, so next, let's us now have a look at volumetric media. So I introduced 2 important concepts, and now I will focus on volumetric media and volumetric media delivery. So volumetric media delivery corresponds to the a technique that captures 3-dimensional space. And so we are very used to 2-dimensional video in the past. So for instance, here is a person playing a 2-dimensional game. And in 360-degree video, we are much more immersed into the situation. So there is a deep absorption into the environment and into the activity. So for instance, this is a Formula One racing game, and you can pretend to be Max Verstappen, and you also see with the virtual reality goggles, and you have the same sensation as if you were in the race car, similar to Max Verstappen. If we look at volumetric media, this is a technique to capture three-dimensional space. So then we also wear VR goggles, and then objects can be displayed, and we can look at the objects, and it is as if the objects are really there. And for instance, we can then play a game, and objects are shown to us. And this is a technology like a virtual reality or augmented reality, and it's really expected to play a key role in the future, also from economical and societal point of view. So if we look at volumetric media delivery in the traditional 3D images, there are two static views. So there is a view for the left eye and a view for the right eye, and these need to be synchronized. But if we focus on holograms, then we add parallax. And parallax, as you can see here, is the apparent displacement of an object based on a change in the observer's point of view. So if the observer changes the point of view, then you have the feeling that you can look around the object, so next to the object or on top of the object or even underneath the object. So you create multiple views, and these are the different movements that you can make. So if you make movements in these directions, and these are called 6 degrees of freedom, then you have a different view of the objects. And for instance, if we make use of Google Meet or Zoom, then typically we have 2 dimensions. And if we make use of volumetric media, then we have 6 degrees of freedom. And there are many important use cases for this. And one of them is the holographic collaboration and conferencing. We also call this telepresence, because a person who is at a remote location is then as a hologram displayed close to you, and it's as if the person is close to you, and you can interact with the person, but in reality the person can be far away. And second important use case is telesurgery, or in healthcare, remote patient monitoring, where you can also display, for instance, in case of an operation, a surgery, you can also show the important parts, and then surgeons can work together or can monitor patients that are remotely. And also very importantly, there is the use case of industrial monitoring and management, so Industry 4.0 or even 5.0, where you can remotely inspect objects that are produced in a factory, for instance, and instead of inspecting them locally, you can inspect them remotely, and then you can decide which of the products are meeting the requirements. This can be kept, and which objects are not meeting requirements. So thanks to these holograms, all these use cases are possible, and there are many more use cases, and I will explain some of them in the next pages as well. So it's important to realize that holograms are not science fiction anymore. For instance, there is a German circus that uses holograms instead of animals. For instance, a hologram of an elephant here. This also contributes to the animal welfare. And there is also the famous hologram of Princess Leia in the Star Wars episodes. And these two examples are local applications, so they are not transported over the network. And if we would like to transport holograms over the network, then the bandwidth requirements are really very high, so in the order of gigabits per second. So then we really need compression to be able to transport all this data over the network. And of course, as we are computer science engineers, these bandwidth requirements and also delay requirements are very interesting to us. And for instance, let's have a look at which bandwidth requirements do we need for transporting video over the network. So if we have high definition television, for instance, as you can see here, for instance, up to 5 megabits per second, then if we have a higher quality and 360-degree video corresponding to 4K, then up to 25 megabits per second and even 16K times 20, so 500 megabits per second. And if we then look at holograms, then there are two important technologies. There is the point cloud technology and also the light fields technology. So in the point clouds, let me explain it with the famous picture here. So this is the Stanford bunny. And if we want to represent this object through a point cloud, as the name suggests, then we will consider all the possible points of the objects in a three-dimensional space. So we will determine for each point on the surface an x, y, z coordinates, as you can see here for this point. And we will also add color information. So red, green, blue information, RGB value. So 6 data points for each point. And if we then have this information for all different points, then we create a point cloud object. And if we transfer this information over the network, then we can create this parallax effect. So then we can look next to the objects, on top of the object, underneath the objects, enlarge and decrease the size of the object. So based on this point cloud information, we can really display it as a hologram at our displays. And an important optimization, because if you have these point clouds, they consume a lot of bandwidth. You really need a lot of data points, a lot of information. And if you make use of meshes, then we will construct triangles, so small triangles on top of the service. And then we also keep the information about the location of the triangles together with the color information inside the triangle. And then we can have small triangles, and then we have a high quality representation. And if we have bigger rectangles or bigger triangles, then we have a lower quality estimation of the objects. So by changing the size of the triangles, we can adapt the amount of data that we need and also the quality of experience that corresponds to the object. So now I explained the point clouds to you, and so when we make use of this technology, then we will focus on the object itself. For instance, here's a person skiing down a mountain, and then making a point cloud of this person is only the person itself, not the environment. But if we also need the environment, so the mountains behind the person, then we need image-based technique. So it's a light field technique. And this is more computationally intensive. There we have to reconstruct a planoptic function, which is a 5-dimensional function representing the intensity of light observed from every position and direction in the 3-dimensional space based on a set of example images. So then we can, based on this planoptic function, we can generate realistic images by indexing the appropriate light rays, and then we can construct and make use of parallax to really, as a hologram, display the information. But an important observation that you probably already made is that if we look at the required bandwidths for light fields technology, they are much higher than for point clouds. So this is the main reason why we typically use point clouds. If we now give demonstrations with holograms, volumetric media, we typically use point clouds But I expect in the future, because we can also model the environment and not only the objects, in the future, light fields technologies will also be very important. So I also want to take this opportunity to introduce a European project to you, which is the Spirit project. It started in 22 and it will run until the end of next year. Here you see the different partners in the consortium. So we have Deutsche Telekom on board, also Ericsson as an equipment provider. I know Christian has a very good relationship with Ericsson. And also universities and research institutes are involved, and imec is listed here. This is my affiliation, and imec is leading this European project. And the aim of Spirits, as listed here, is to build a scalable platform for innovations on real-time immersive telepresence. So the telepresence that I explained through holograms that are shown close to you, and to allow for conference use cases. This is really the aim of the project, to build demonstrators and innovations on top of this. So it's important to understand that in order to be able to provide telepresence through holograms, really as a service, then we need innovations on different levels. So we need innovations at the network layer, on the transport layer, so different transport protocols. I assume you are familiar with some of them. And also at the application content and security layer, there is a need for several innovations. And these are covered inside the Spirit project with these partners. And let me show you a main diagram of the Spirit project. And here I make use of the virtual network functions that I introduced in the beginning. So I explained you this is an important concept for softwarized networks. And we also make use of them. These are the key elements in the European project Spirit, where we have a lot of virtual network functions to enable volumetric media delivery over networks. So we have virtual network functions for compression and encoding of the streams. Then also virtual network function for transport, buffering, merging, and synchronization of streams. Also for view prediction, to predict where a user will most likely view, so that we can provide the highest quality there. For decoding, and also then for rendering and monitoring of quality of experience. So we have different virtual network functions, and then we have to deploy them on the available network infrastructure. And there is edge computing, so we have data centers close to the end users. And if we need low latency, then we should deploy some of these virtual network functions very close to the end users. And others we can deploy inside data centers, inside a cloud computing environment. So it's important that we make a right decision where to deploy these VNFs in order to guarantee high throughput and low latency to the end users. And so we build a demonstrator where we have in Deutsche Telekom, which is based in Berlin in Germany, and then University of Surrey is based in London. We build a demonstrator so to demonstrate telepresence with people present in Berlin and in London, and to show holograms of each other and interact with each other as if everyone is local and close to each other. And the Spirit use cases that I want to show you are listed here, and this corresponds to typical use cases when we talk about holographic-type communications. So we have the real-time human-to-human interactions, so holographic conversations, when you want to have a conversation with a person that's not locally there, but at a remote location. And also importantly, real-time human-machine interactions, where we interact basically with, for instance, mobile robots, autonomous mobile robots. And there are two options. Either these are human-initiated, so then a human requests a mobile robot to take up a task, for instance, to supervise factory plants, for instance. So you give the robot a specific task, and then the robot takes care of this task. Can also be machine initiated. This means that mobile robots, they are autonomous and they will alert humans when they observe something or they want to solve a contextual problem and they want to have guidance. Then they contact the humans. There are also open calls in the Spirit project. I just mentioned this very briefly. So other parties, research institutes or companies, they can also make use of the Spirit platform and demonstrate their applications. And the applications that are covered, and I will just go over it briefly, is in the healthcare domain, retail domain, education, training, entertainment, manufacturing, so Industry 4.0, 5.0, and also in the tourism domain. So you see many target application domains. So there is really a lot of application potential of holographic type communications. Okay, and a very important question that we should have in mind, and that you typically also ask yourself when you consider the high bandwidth requirements. These are really huge. And then the main question is that you ask yourself, can the current infrastructure deal with this volumetric media delivery? And for this, we did many experiments in our lab. So based on point cloud scenes, for instance, of the objects that you see here. For instance, if you have 4 of these objects, then we require close to 20 gigabits per second. And then we did experiments in our lab where we make use of adaptive streaming. So the adaptive streaming that I explained you in the beginning, this technique we used for transporting the holograms through point cloud scenes over the network. And now we extend the basic technique by considering different objects. So as you can see here, we consider 4 different objects. And for each object, we have a low quality version, a medium quality version, and then also a high quality version. And at the client side, this is now at the goggles that the user is wearing. There we make a decision based on the available bandwidth, and for each of the different objects, we make a decision which quality levels can fit. And for instance, here, as you can see, if the available bandwidth is low, then we can also only use for the 4 objects the lower quality. If we have more bandwidth available, then typically we will select the objects where the user is watching at. So where the user is paying attention to, these we will give the highest quality, and the others can have a lower quality, and so on. So we can dynamically change the quality levels based on the available bandwidth. And it's important if you do research on holograms, holographic type communication, as Christian mentioned in the beginning, it's important to not only focus on objective quality measurements, but also do subjective studies. So involve users and let them interact with holograms, and then also let them give their personal opinion on the quality levels. And so we did experiments in our lab. You see the settings here with 4 point clouds and different video sequences and different configurations of available bandwidth and efficiency of the viewports prediction with in total 30 participants of the subjective study. And here you see a typical output. So the mean opinion score is the output that users give. So if they really like the quality, then they give 5 on 5, typically 5 stars. And this corresponds to 100. If they only give 1 star, 1 on 5, this is a score of 20. So this is the cumulative distribution function that you see here. And depending on the scenario, so in the low bandwidth scenario, medium bandwidth, high bandwidth, and even unlimited bandwidth scenario, you see the mean opinion scores of the users. And as you can clearly see from this observation, the mean opinion scores are less than we expected. So we expected in a high bandwidth scenario or even unlimited bandwidth scenario, much higher mean opinion scores. So it really means that there is something else that we should pay attention to, because the mean opinion scores are lower than we expected. And the main reason is that the techniques that we use to the adaptive streaming does not cater to the latency requirements. So we not only need innovations at the application layer, as in the example that I gave with adaptive streaming. This is basically an application layer optimization. But we also need network layer optimizations, and also a cross-layer based end-to-end architecture for volumetric media delivery. And this is the platform that I want to introduce to you. So if you want to achieve immersive, so that we can be deeply absorbed into the contents, volumetric media delivery, then we really need a cross-layer approach. And here you see the different layers. So we have a holographic end user 1 and a holographic end user 2. They communicate with each other. So here you see the cameras that record the person, and then here a hologram is displayed. And so we need optimizations at the application layer. So we call these end user optimizations. So at the client side or the server side. Also optimizations over the top and transport optimizations. And then also optimizations with respect to network architecture. So let me briefly go over these 3 layers. I will keep it brief because I want to meet the time requirements and the latency requirements that Christian gave me. So in terms of end user optimizations, there are optimizations possible at the client side and at the server side. So at the client side, there are different feeds, as you can imagine, visual feed, audio feed, and tactile feeds. And we can make use of viewport prediction. This is a client-side optimization. So we try to capture where the users are most likely watching. This is the viewport that we try to predict. We also need to synchronize the feeds. And also, importantly, and this is a topic that, in my opinion, will be very important for the next years in research, is a cyber sickness assessment. Because this is a feeling that users sometimes get when they make use of virtual reality applications. They can get cyber sick because they expect an object to be at a certain location at a certain time, and if this is not the case, then they can feel unwell. So it's important that we can predict and prevent this, so that it's convenient for users to make use of holographic type communications. And at the server side, we can also make use of tiles instead of entire objects to divide them in different tiles. And then the tiles can again have different quality levels. So then we have more freedom to decide which quality levels so that we can adapt to the available bandwidth. And then in terms of the over the top and transport optimizations, there it's important that we make use of the right platform and technologies. So if you make use of HTTP adaptive streaming, the technique that I explained you, then typically we focus on the quality optimization. We optimize for the best possible quality. And then if you use other techniques like RTP, UDP streaming, or making use of the web RTC together with Quick platform, then we really focus on latency optimization. And here you see the pro and cons of the different techniques. And for holographic type communication, we in fact need the best of both worlds. So we need a combination of these. And there are different techniques that are out there that we can use. for combining advantages of different transport layer protocols, intelligent buffering techniques, and also smarter retransmission techniques, HTTP push that comes with HTTP 3.0, for instance, that allows us to obtain lower latencies. And then at the transport layer and control layer innovations, we also have the partial reliable quick, also called PR quick. So quick is a transport protocol by Google, and these are extensions that in my team were investigated and recently published. So here we make use of partially reliable quick, where some of the tiles we can make them reliable, because here most likely the user will watch. This is a person on a surfboard, so most likely you will watch the person and the surfboard, and not so much the environment. So then we can give these a higher quality, make them reliable in the delivery, and the others can be unreliable, so they can be displayed in a lower quality. And then finally is need for innovation on novel network architectures. And here really the optimizations with virtual network functions that I explained in the beginning. So the service function chain optimizations are really important. So the efficient placement of these virtual network functions and making sure that we meet the requirements in terms of latency and throughput. This is really an important technology. So the main aim is that we can very conveniently, very comfortably make use of holographic type communications and communicate with people as if they were close to us. And in my team, we designed a platform for this, and we call this SR-Fog. So it's based on segment routing and also the concept of fog computing. And we make use of microservices, and the microservices then they correspond to the virtual network functions, and we optimally place them also by following the Kubernetes architecture model, placing them efficiently inside pods, inside containers, to be able to make sure that the content delivery is very efficient and very convenient to the end users. So here you just see an example of VR user 1, VR user 2 that communicates with each other. And in order to enable this, we need several virtual network functions that are shown here for scene merging, quality scaling, movement prediction, and so on. And then we decide which service we will put in which pod, and then where we will deploy it. So, and we have different options. This is a cloud environment, this is an edge environment, and this is a fog environment. This is a Raspberry Pi environment. And then we decide where to deploy it, these virtual network functions, and then we can host the service and really enable the holographic type communication between the two users. So let me now go to the conclusions, Christian. So there are many open challenges and topics, and I'm happy to learn that also Christian is interested in the holographic type communications. So I look forward to collaborations. I believe there is a need for further research in terms of network optimizations. So I list several topics here. Also, in terms of predictive orchestration and distributed networking will also be very important. Also, intent-based networking will be important. And also application optimizations that I explained, different techniques that I explained need to be further investigated, optimized. And in my opinion, this is really a challenge that we have to tackle with a lot of researchers, both in industry, both in academia. And then I believe we will have, or we will be able to make progress and to obtain very interesting results for the future from an economical point of view, but also from a societal point of view, as I explained. So this is also important to me, that we can also make some progress from a societal point of view. So with this, Christian, I would like to pass the floor back to you. Thank you.
Thank you, Philip. Very, very interesting stuff. I was browsing through the Spirit here deliverables, looking into the what you call the platform. I was looking for some GitHub repositories where that students could start playing with these volumetric media concepts, and that was one of the challenges that in our group we encountered, like the barrier to entry into this research, because you don't have these cameras, the end devices so easily, was high. How do you see it? This how to start and what open source components to put together? Is there? Do you share my feeling that it's not so easy right now to start, or
Yeah.
are there some? Is there some light? Are we going to see more open data, more open source to
Yes.
facilitate
Yes. Yes.
research?
Yeah, excellent question. So in my opinion, I really hope to see a significant increase in the amount of open source software, and definitely from my team. For instance, the SRFOC platform that I mentioned, we made this open source, so it's mentioned in papers on this. It was published, for instance, in CNSM. Previous editions of CNSM conference, and there we also have the GitHub links to it. So I definitely see a trend in research and publications that a lot of researchers also are moving towards this direction. And also what you mentioned, Christian, in terms of barrier, in terms of equipment that you need, so cameras and so on. This is indeed true, but even with a single or with two cameras, you can already do an interesting experiments. And once a point cloud is created, so the first step, in my opinion, is always you have to create a point cloud. And when this is created, you can publish it or you can share with other researchers, and then you can start doing your research, and then you don't need the camera anymore because you have the point cloud that captures everything, and then you can do the calculations, the visualization of it. So if we share point clouds, and in my team we have point clouds that we make publicly available. So based on this, you can do a lot of interesting research, even if you don't have the camera or the expensive goggles. So it's of course good to have a few of these goggles, so that students, researchers can have a feeling and get acquainted to the environment, holographic environment. But there is no need to have 20 or 25 of them. Even with a limited number of goggles and cameras, you can already do very interesting stuff, in my opinion.
Mhm. Nice,
Well,
nice. Yeah, I guess what some of my students have already used your point cloud videos. I can see Alan is putting here a question, a very technical one over the YouTube chat. Uh, he's asking about the partially reliable quick. If you
yes.
see eye tracking on mounted head devices as a mandatory feature.
Yeah. Okay. Okay. Yeah. 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 That's a good question indeed. So your student has clearly have a detailed look at the paper. Yeah. So the paper was published in IEEE Access, I think a few months ago. And there we indeed did experiments where we included viewport prediction and also eye tracking. And the main goal of the eye tracking was to make a prediction where the user is watching. So then we can provide the highest quality levels where the user is watching, and then the background surroundings can have a lower quality version. But if you have very accurate viewport prediction, then you don't need the the eye tracking. So eye tracking is mainly used if user is not moving a lot, like myself now. I'm not moving a lot. So I only make very few movements, and then eye tracking is useful. But in other applications, then users are moving much more, and then you have more data to make a prediction. So if user is moving towards something, then most likely during the next second or 2 seconds, the user will also move following the trend line. So if you have trend lines available, then you don't need so much eye tracking. But for more static scenarios, like myself today here, then eye tracking is more useful if you want to optimize quality level. Of course, if you have sufficient bandwidth available, then you don't need it, because then you can provide fairly good quality at all time, and you don't need to make a distinction between high and lower quality.
Mhm.
I hope this answers to some extent the question of your students. Thank you.
Thanks, Philip. So I learned, I was last week close by. I couldn't make it to Ghent, but I was in Antwerp, in UCNC, and I learned there is negative latency. That's I hadn't uh, learned this term. And it's about prediction. So if you can predict the next frame or the next packet that will arrive, you achieve negative latency. Just thinking about this concept, I was blowing my mind, because you mentioned prediction a couple of times, right?
Yes, yes,
So
yes, 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 yes.
I guess then AI, ML, artificial intelligence, machine learning are also at the heart of many of these topics that you have put here as research, as a tool to solve many of them. Can you mention some AI or ML to there's so many enthusiasts that want to use ML, AI, beyond predicting movements? What else do you see applications for this?
Yeah. Okay. 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 Very good question. Very good. So in the past, this machine learning, artificial intelligence was typically used to predict movements of users, but also in terms of cybersecurity, or excuse me, cyber sickness detection and possibly prevention. There we also use machine learning techniques based on a lot of data that we acquire, and also physiological data from users. So also heart rates, maybe stress levels, blood pressure, and so on. So physiological data. This generates a lot of data captured from a user's body, of course, if they are willing to participate to such a study. And then based on this data, you can also predict when a user might feel unwell and experience cyber sickness and so on. So I believe in that region, there will also be a lot of application of AI and machine learning. And also, as I explained, so the placement of virtual network functions. So the software modules that has to be started in the edge or in a cloud environment, and this has to be in a very dynamic way. And there we will also make use of AI machine learning to determine where we should put the components, when we should move it to another location, and so on, because this is something we cannot do manually. It's impossible to make especially when it's very dynamic, and we have hundreds of thousands of simultaneous holographic-type communication users. Then this is something where we will need AI-based network service management techniques to make sure that all these software components run properly, have sufficient bandwidth, latency is not too high, and so on. So there definitely I see use of machine learning in very large scale environments. And there my team is also focusing on edge clouds optimizations, making use of machine learning techniques.
Nice. And I guess there are also opportunities for hardware acceleration, right? For smart NICs, FPGAs. these
yeah,
BNFs, probably the performance, the latency. That's also another subject, right? As well.
yes, yeah. That's definitely another subject. Then hardware acceleration can be beneficial in the cloud, so in the data centers, so that you have a higher throughput there, and even lower latency. For instance, if you have an encoding or decoding, then with hardware acceleration, that the decoding or encoding time is reduced significantly. But you still have to take into account the latency of the network, and careful placement of the components will still be important.
Okay.
But definitely hardware acceleration. Also for security, this is a topic that I didn't cover, but security is also a topic in Spirit project, and there also hardware acceleration is also considered um, to make sure that the security protocols can be run properly.
Mm-hmm. Good. Very interesting stuff. I like the connection, the possibilities of this physical world, and to understand the quality of experience, very user-centric, very right.
No.
Trying to, I can imagine different types of persons, of users will really evaluate their experience. Yeah. So, I mean, it looks to me like it's a very hard problem, this quality of experience. The objective metrics, as far as I understood, are not fully sufficient, right, to
Yeah.
assess, and then the users may change a lot their scores. What is the lesson learned around the QoE that you could highlight, or what is the current state of the art, or what are less understood? Of course, you put it here to increase QoE, but what would you highlight on this QoE objective studies?
Yeah. This is indeed a very important area, and there is also a lot of standardization and efforts by the MPEG consortia. So they also focus a lot on standardization of objective metrics, techniques for subjective evaluations, to standardize them so that they can serve as a kind of a benchmark, so that if companies say quality of experience is this high and another company has another number, so that we can compare them. So there is a lot of efforts, not only in research, but also in these standardization bodies. And they also focus on holographic type communications already, since not for so long already, but 2 years or something. They really start focusing on this and on QE models for holographic type communications. So this is an important topic to keep up with the standardization efforts and so on. And then my approach is typically that I start with an objective evaluation where I measure the received qualities, the obtained latency, so things that you can really measure. And then from this, I try to derive whether there was a decent delivery of the content, and try to put this in a percentage. And then next to this, then I do subjective evaluations to see if the objective evaluation is indeed correct. And then there is really a feedback loop, because based on subjective experience, sometimes there are new elements that you should take into account also when you do the objective evaluation. That the user is pointing to something, and that is really devastating for the quality. And then you should take this into account.
Okay.
And so it's really iterative approach in my opinion. And my goal is always to find the best objective metrics, because if you want to make the system autonomous system, then and in real time updates, then it's very hard to do this with subjective evaluations. So in my opinion, subjective evaluations are key to improve the objective
Right.
evaluations.
And the subjective, are they sufficiently well standardized and documented, or do you need to find your own methodology?
Well, yeah, there are a few conferences. For instance, there is the COMEX conference,
Yes.
and so it takes place next week in Sweden. And this is a typical community that publishes a lot of papers on this. And they have some guidelines. For instance, you need at least 25 participants, and you need to ask them at least 10 different questions, and so on. So they have some typical approaches in their published papers, and I typically follow these guidelines, and I sometimes also publish in these COMEX conference. For instance, last year, 23, it was organized in Ghent. I organized together with my colleagues, of course. We organized COMEX in Ghent.
Nice, nice. We'll have a closer look at this. Okay, Philip, it's time. We need to uh, get the timing right. The students now have other classes. It was great talking to you about this very exciting topic. As I mentioned, in the Smartness Research Center, that we have still 9 years more to go, and it's with co-funded with Ericsson and the FAPESP, Sao Paulo funding agency. We have a track on HTC, on holographic-type communications. Your group is a reference. The Spirit project is also one of the inspiring ones, and that we are following and reading the deliverables, looking for the open source code and data. Yes. And let's catch up on the possibilities of collaboration, of student exchanges, that we have also good funding to send you our PhD students and stay and enjoy beautiful Belgium. Okay, thank you. Thank you.
Thank you, Christian, for the invitation and for your interest, and all the best to the students. So all the best with the academic year finalization. Okay, thank you,
Philip.
Yeah.
Take care. Bye.
See you soon. Thank you.
Thanks.